modules were generated for a commercial. Later it is given to the, made it commercialized. So like that, there are a lot of advancement happening where how we can use AI/ML for manufacturing. Once it is proven and once it is become patent free, then we will give it to the public. In the sense, all our customer can use that. So, and as I said, we are not only supporting from software point of view, we have something called Material Center, which is used by US Army for a testing, and all their data will be managed by us. If I have a 4 research business unit in the same organization, let's take Safran or GE, they have technical center in India, US and let's say in Europe. So there will not be any repetition of the test done. So all of this will be uploaded over here so that the colleagues can access any of the relevant test it is done by within the organization. So those facilities also there. And what does it include? It includes machine information, any new material development, property related if I am working on a new material development, then the manufacturing related part detail and what kind of process we followed. All of this will be available in the cloud-based platform within the organization. So yeah, so this is what we learned today. So I'm almost end of my presentation. So this is one of the drone startup in Bangalore. We have optimized for a drone. So this is a place for a battery and camera hold, and we have printed with SLA material as well as with FDM for a proof. And this is a bionic design for a medical implant and other stuff. This is a industrial application using DFAM. So all of this were DFAM examples. Couple of other design which we have used. This is a wheel up which we are talking about. Other things, again, this two are wheel up. This is for a aerospace application, then application of tree root structure, satellite, and other application. So you can come up with any of this design, not only lattice, varying lattice plus solid and other stuff. One is applying lattice, but after applying, we have to ensure the durability and stress. In fact, we can do that. So if you have any further doubts, you can just write to me. So you can write to me or our global expert. So whatever we have seen is more of a industrial. So what we do for academic, I have a couple of slides for academic as well. So now we have come up with SIM Academy under Hexagon, where we do the certification, collaboration, and connect. The program is called. So this is already implemented in RMIT and many of A-Star University and other colleges. So where we run the program, so this structure is already available with us, or you can replicate the same what it is already done in RMIT and other stuff. So if you are interested, I will connect to the respective team, so who will be looking after this curriculum development and the software. So this is our development in industry, so which is already done at CMTI Digital Twin. The same part designed for a casting, machining, and 3D printing. So all of this, the same set of loading condition, but a different part which will be done with a different manufacturing process. And the inspection using robotics. So this is more of industrial application where we create a digital twin reverse engineering for additive manufacturing process. So going forward, so you need not to use or install any of the software. So all of this will be available on the cloud, which is called Nexus. So all the tools and the data preparation software, everything will be on the cloud. Each students or faculty will be given with the login. You just have to log in and you open that software. No need to install, no compatibility issue, nothing. So everything will be on the cloud. So only challenges with the defense and government, they don't want to go for a cloud as of now because of the security purpose. But this is already available, and many are moving more of a subscription and cloud. Cloud credit will be there, so it will be some free credit. So after that, it has to be pay for usage. But for them to experience, it is easy to log in. They can log in as a Nexus, hexagon.nexus.com. If they can go, they can log in just to understand the workflow and what are the tools available. And third-party tools also now integrated with this platform. Yeah. So, and more importantly, so for our existing customer, we run something called a sixth sense. So where our existing customer need not to be in the customer in the sense any user can come and present their idea. So let's say you have come up with your own unit cell design and you want to make it commercialize. So we have chosen one from IISc. So there is one professor has come up with one of the concept of, it's called EMI, the emission measurement index. When I have an electric component in the system, how much it is emitting for a surrounding component. So now we will be, Hexagon will be acquiring that concept, and we will fund to develop that concept. So patent discussion, other things will be discussed later based on the funding. So if you become customer, you have chance to participate in sixth sense. So whatever idea you have or any unique concept you have, so you can come and present. The rest will be funded, will be done by the Hexagon. So one we selected from battery range calculation. Another, which is this year there are two ideas selected from India, one from IISc, one from another professor, I don't remember, but the concept is on calculating the vehicle range. If I have a vehicle which is of let's say 600 kg, and if I have a 66 kilowatt battery, so what will be the range? He has come up with some equation and basic algorithm. So that will be funded by Hexagon to develop as a commercial tool. So like that we run this every year. So if you have any idea, just come register to Sixth Sense and you will get a chance to present, and it will be funded by us. And you have a lot of white paper case studies available in your website. If you are interested, just go through that. Yeah, so with this, I will end my presentation, and I thank you for your time. So if you have any questions, I am open. Or you can write to me as well. I will just, okay. It is there in the first slide, so you can write me. And it's already printed in the handbook. Yeah, any questions?
So the software can be used as the artificial intelligence, right?
Yes.
Suppose if I am sending my original design to optimize, will the software able to identify whether the design has a scope to optimize or not optimization?
Yes.
Without the simulation, before that only it will identify.
So it will stop at one point saying that, so it's an iterative way. It will keep on running. So when the last iteration and next few iteration has seen no material reduction, it will stop saying that there is no scope for a further optimization. Now you can come back and do any modification. For example, you have not chosen the material. Now you choose the material. So then it will rerun. So like that. That is open.
One more is that apart from this generative design and topology optimization, this software can be able to identify like conformal cooling channel, part consolidation.
That is thermal management. That can be done. So it can be done because many heat exchanger were 3D printed. We have done. I have a live example with Bharat Forge. We have done that conformal cooling. So not only optimization, after printing, how do you ensure no powder is struck, no material is struck inside a conformal cooling channel? That we have done it. I have case study. If you can, I can share that.
Sir, finally, which one is better compared to subtractive and additive?
When complexity is high, additive manufacturing. And complexity is simple, subtractive. So additive manufacturing, we say that it is not going to replace anything. It will be complementing, because complex design with conventional is difficult. So there additive plays major role. So it will be one of the substitute. It will not going to replace casting, machining, no. Because many 3D printed were machined for a better surface finish. Yes.
How an educational institution can associate with the SIM Academy?
SIM Academy, I will forward those details. It is more like if you have any, you might be using any of our tool. You might be using Adams or Nastron. So if you have any idea respect to that, you can go and register. So that it will be screened. So first India level they will screen, then they will take it into the global and they will fund it. So that is open. We have live example of that emission calculation and the range calculation. There are two projects which is already funded for India. So that is going good. Yes.
Sir, you talked about rain process simulation.
Hmm.
So, which type of process? I mean, basically, is it LPBA or are you simulating other anti-manifold?
Other also. There are 6 to 7. I can simulate FTM, SLA, TED, LPBF, then binder jetting. So these are the different module because in the background, science is different. The material we use, in DED we use wire or powder. In LPBF we use wire. Then SLA and FTM we use plastic. So these are the different module we have to choose based on the application. The same design, what you can do is you can put into all of this and understand which is better. That also you can do.
Also, which type of support structures are, I mean, basically LPBA as well as FDM. Which type of support structure is being used for simulation?
Yeah, support structure, that itself we have, if you look at, we have solid cone, then,
This is there, tree is there.
So what we always say that where there is a more load coming towards the base plate, we need solid. Where there is only overhang, there we use this cone. So further you can optimize using local support. Instead of giving support from the base plate, you can give local support as well. For that you have a lot of software like AM Studio, Magix, even SimuFact. So those software need to be used for a support optimization. Yes, you're asking.
Can we get this software for research purpose? Because we have a machine and we are facing difficulties in simulation and all those things.
Yes,
So can we
that is SimuFact is a right one for a machine.
Is there any trial version for students?
Might be available. So trial version, what happens? You will not get the third-party tools integrated in the software.
Yeah, whatever
But you can try.
that we can.
Otherwise, you can write to, who is the contact, or you can write to Samir and get the research license only. That is
We
possible.
have a machine is there, but we are somehow we are failed in the analysis and all those.
You can do.
We want to explore it.
That is a major application. It can be done. You name any service bureau in India, intake, everybody asks this tool.
Yeah, that's
Yeah, you can do that. Yes. And it's an outcome of, it's a spin-off of SLM researcher from Fraunhofer University. So they developed, I think, 12 years back. Now we are commercializing it.
Is India, SLM India recruiting any students having AM skills?
We have our own recruitment. Also, there are many of our customers who is looking for it. So, if you have anybody, we are happy to.
Share the CV.
Yes, yes.
Please help us know some. Many of the students are working in that area nowadays.
Recently, I have put WhatsApp status. Anybody with 1 year experience, please reach me.
We will share it.
There is a requirement, as I said, even for a startup. So they might be having good experience in design. AM is something we have a shortage of skill candidate. That is there. Yes.
Yeah, but unless they work in any industry, they don't get experience, right?
Yeah, there.
But their PhD,
Yes.
the skill they acquire.
But nowadays, if you see, most of the colleges, they are also investing on this. So AM lab setup. So good to see. Many engineering colleges have a metal machine, which is expensive. So one. So like that. So previously it was only FDM. Somebody used to buy desktop. Now metal machine also investing and lot of research. So going good. Any other questions?
Sir, is it possible to optimize the medical implants like a TKR and
For that we need a CT scan data. It can be optimized, but we need CT scan data. If we have CT, it can be done. So there is one YouTube video you can go and watch.
Sir, I saw that most of the doctors they will not show the patient this is implant nothing but titanium, aluminum, nothing but tungsten. They only give the treatment and and how the implants are sustained in our body.
That they have tested already. They have taken a safety factor, all these things. I think they
Before implanting, they're asking which material you want.
Yes.
Whether you want titanium, gold.
Most of the hospitals they are asking.
Yeah, that is true.
Which material you want based on
So,
the cost you
that is designed actually based on the even no we I was there in one of the hip replacement. So they will consider the weight and other stuff. They know whether it will withstand. Most of the time it will withstand because that is designed for that.
Yeah, if there are no queries, we thank from all the department as well as from the organizing team and the participants. Like Santosh has came without hesitating with one word. He has accepted our invitation and from Bangalore he came here to deliver. It's very thankful on behalf of our organization. Thank you, sir. And regarding also we have Professor Madhusudan Reddy sir. He is DMRL director earlier. Now he is adjunct professor. You can interact with sir also if you have any doubts regarding this additive manufacturing, welding as well as. Thank you and all. Okay. And regarding the afternoon lab sessions, we'll our lab. One is wire arc manufacturing lab. Another one is powder bed fusion lab. Okay. We'll be at 2:30. We'll go to WAM lab first, wire arc manufacturing. Then we'll come back to powder bed fusion lab. Okay. The ground floor you can assemble. Our research scholars will guide you where we can take you. Okay. Thank you.
This afternoon session is a probably very interesting session which is going to be addressed by Professor Joshi on recent trends and research opportunities in manufacturing, which will be more interesting for all of us. So with this I request Professor Joshi to address the participants.
Have any, it is meant to be a valedictory session with no specific agenda. So let me begin by asking all of you, did you enjoy the course? Did you like it? Yeah. Was it an overload of information? Did things go too fast for you? But that's life, you know. When you have such a big cross section in the audience, it doesn't go at everybody's speed, right? Some people find it too slow, some people find it too quick. So before I get into something else, I'm going to quickly ask you if you have any questions. And I hope all of you have my email ID because, as I said, I don't want this to be a 5-day thing. I want you to think that there is a permanent resource available for you guys if you have questions. So feel free to ask. Yeah, but are there any pressing questions without which you can't sleep at night? Yeah. No? But that's good. Then what Professor Saab and Dr. You have a question? Yeah, okay.
Yesterday you asked me about, teach me about the battery electrodes.
Yes.
That is based on lithium.
Yeah.
Currently,
About batteries or what?
why sodium is replacing lithium, I think
Yeah, that's not relevant to this course, but let me tell you about why we started the lithium-ion battery thin film work, right? I mean, our idea at that time was to show that thermal spray can be a good platform. It can be a platform to provide a method that will help in thin film battery development. So from my perspective, if you're looking at constituents that can be coated, yeah, then it doesn't matter if it is sodium ion or whatever. Tomorrow you change any of the materials that I showed to something else, new materials get developed, yeah, it doesn't matter. And that was the point in starting that project, yeah, to show that it can be a good platform for thin film development, yeah, so that you don't need vacuum, you don't need to do it in a chamber, you can quickly try any new material that is appearing promising and do some at least preliminary testing. Exactly, right? And it's also amenable to large area deposition. So it was and is meant to be to demonstrate that this is a good platform for technology development. So It was, so in my opinion, the lithium based materials that were chosen were just as an example or as a case study, right. So, it should be extendable to many other things. Any other questions at this time? No? But then I was just saying that when we were discussing briefly yesterday what we should cover, then Professor Venugopal and Dr. Manja said that one of the things we could talk about a little bit is about what are the interesting new areas of research, right? And that's something very nice to discuss at the end of 1 week like that. Yeah, yeah. Some of you BTech guys may think, oh, this is too far ahead. Yeah, which is perhaps true, but at least you know the direction in which the field is going, right? I have also been meeting several of you who took time from me in the evening, and I met many of you, some of you wanting to do research, some of you already doing research, and I really enjoyed my time. Doesn't matter who came and spoke to me. I liked spending time with all of you. But there are a couple of comments I must make, because people ask me, oh, what research should I do? What review paper should I write? Correct? I must say that first of all, selecting research area is a very personal thing, right? Nobody can come and ask someone else what research I must do, correct? It has to first of all be a personal choice. It must be consistent with what your interest is, what your passion is, correct? I can't tell you what research you must do. You must like, correct? If tomorrow someone comes and says, ask me to do something in extractive metallurgy, I'll say I'm going to retire. I'm not interested in doing that, right? Because I must be passionate about that area. You should also be real, correct? You should worry about local considerations. You cannot say that I will do something very hi-fi. You must understand what are you equipped to do, right? Some of you are from very small engineering colleges, right? It's great to have a big ambition, but is it realistic that you can do something on PBF tomorrow? Can you ever get a PBF in your college or university? You should think about those kind of things. And if you can't do that, what facilities can I access from my collaborator or whatever? These are important aspects. Third one is compulsion. Let's say I have a partner, and I talk about this a lot because for me in Sweden, I don't get any funding unless I have an industrial partner. Once I have an industrial partner, the industrial partner kind of sets the boundaries for me. Yeah. So, in response to some of the things that I have discussed also with faculty, what kind of samples can I say? I say I can send you superalloy samples. Why do I say that? Yeah, because my partners are GKN Aerospace, Siemens, right? So, my powder bed fusion machine is always busy doing superalloys, correct? So, if someone comes and says, I want some 316, you said you can give me AM samples. I can't give you 316 because for me it's not easy to do that. If I have an ambition to do something on 316, I don't have that luxury because my partner will say, forget it, we are not interested in 316. We only want not just nickel based superalloy. Now I understand 718 completely. I want you to work on CM247. That's a compulsion then for me because my money is coming from there, correct? So, there are compulsions like that. Imagine that there is no compulsion from your partner, but you are applying for funding, right? Sometimes in India we are fortunate, we don't have to apply for funding. We get some money from the department. Sometimes you may not get. Then you need to write an application for and pick a research area that resonates with that funding call, right? People come and ask me, oh, are there any India-Sweden calls for funding? Yeah, there are. They come once in a while. The last funding call for India-Sweden funding support was on bio, right? So, if I want to apply for that funding, I am forced to pick a research area that is related to bio, correct? So, there are many things that you need to think about. So, do not go around asking people what I should do research in, right? You have to decide, yeah, based on one or more of all of these, correct? So, that is a general comment, but I am going to talk to you a little bit about, in my opinion, what are interesting research areas in AM, what are interesting research area in coatings, and are there research areas that combine both of them somehow, right? So, I am going to only give examples. I am aware that some of you have trains to catch. So, we will try and wrap it up by 3 o'clock, and if you have questions, I will take that. If those of you who want to go can go, correct? So, I am going to talk about a few things that we are doing, because I think these are areas where we do not have good answers yet. Yeah, one of them is multi-material AM. I heard some questions, that is the reason I put that, someone doing copper and stainless steel or something like that, even here on this campus. So, we are also working on multi-material AM, and that is a very good area to work on. Because the playground is wide, there are many things we do not understand. What we started doing, for example, is trying to combine a nickel based superalloy and an M Crawley. Yeah? To be honest, this is step 1. Yeah? Our next step is to combine M Crawley with yttria stabilized zirconia. That is the real big challenge, but we started with this. So, we have been looking around, trying to solve many problems, building different kinds of layers, right. We started with 4 layers, 5 layers, more layers, and suddenly somewhere we begin to find cracks like that. Yeah. I have had at least couple of students come and talk to me from this campus talking about these kind of cracks. Yeah. What does it mean? There is nothing wrong that you are doing, it is the same as what we are doing, different system, but it is challenging, correct. So, multi-material, when you look at multi-material, there could be several reasons why these kind of cracks originate. Some of them could be chemistry driven, sometimes the crack could be driven by temperature also, right. So, we are trying to kind of explore both. We have a partner that is kind of doing modeling and trying to identify if there are certain zones of chemistry which make themselves prone to such cracking, right. So, we have been looking at that. Yeah. Sometimes we are successful, this is a 12 layer structure, in some cases, yeah, we get cracks. Why we do not get cracks and why we get cracks here is something that we are not sure, but trying to understand. That is part of research. You cannot say, oh, I got this now, well done, I will move on, right. I would like to understand why this is cracking and this is not cracking. Just like we spoke about columnar coatings, I like to understand why I get columns and why I do not get columns sometimes, because that then forms the foundation for you to do some neat research later on, right. So, this is one of the areas that we have been working on. This is another example that I picked, because a smart student from this campus from NIT Warangal, Hemchandra, he joined us 2 months back or a little bit less, and we have asked him to work on this problem, right. Our ambition is to develop a flagging system. What is a flagging system? We want to understand the process so that if something crazy is happening, we want to know, right. By measuring different things, we want to know, oh, this does not look right, I must have some kind of a feedback to correct my process, so that I can eventually get a process that is robust and will give me no defects or minimum defects, right. So, again, I do not want to get too much into details, but we have been looking at all sorts of machine variations that can happen, sometimes inevitably. So, Hemchandra, for instance, is working on wire DED. So there could be an excursion in the wire feed rate, there could be an excursion in gas flow, voltage, current. So we are trying to see if something crazy happens here, yeah, how does it reflect in the quality of the coating, right? So that is what we are trying to study. It's a very complicated map. I don't want to at this point get into those details, but what we are trying to do is look at this is an example of wire feeding, right? This is how you want it to be, but sometimes there is stubbing, sometimes there is separation and you get droplets, and if one of these things happen, what happens to the bead, right? That's what we are trying to understand. And if something like that happens to the bead, what does it mean to the microstructure, correct? So that is one area that we are quite interested in finding out how the variation in input reflects on the output, right? So this is the kind of, so we are to understand this, we are intentionally making changes in the input and trying to see. So for each change, we know the exact location when we do this bead where that change corresponds to, and we are trying to see those kind of changes here. Let's say I have a sudden spike, 15% spike in my wire feed rate. What does it do to the microstructure at that specific location or little bit after? Is there a lag? Is there a change first of all? And if there is a change, is there a lag, right? That after some time you begin to see that change. So we are looking at that, and already in a very short while, this is everything that is done by Hemchandra. He is doing very good work there, right? So this is a real data from what we have collected. So this is an example of if the wire position changes, and this is intentional, what happens to, for example, the conductance, right? We are trying to look at that. So that's just an example. Let's talk a little bit about coatings, right? Coatings is always a very hot area. We are looking at new approaches to process coatings. We spoke about powder coating. We spoke about using suspensions when the powder is very fine and there are problems with feeding. Yeah, but we want to take it to the next level. So suppose I don't want to use a powder at all, correct? I just want to use a solution precursor, right? So we started off asking this question: can we not use a powder at all in thermal spray and get columnar coatings? We have already spoken about why we need columnar coatings, right? Because of strain tolerance, etc. Yeah, and the hypothesis that we have been trying to work on is, if you can get columns with a suspension, you should be able to do the same with SPPS if you are forming particles during flight, right? Because then the mechanism is the same. The fine powders just go along with plasma flow lines and then they should form columns, right? So that's an area of research, correct? So what is critical based on what knowledge is available in literature is, if very fine powders exist from a suspension, they don't travel straight, they travel like that. They go with the plasma drag line and then they deposit on these asperities or roughness, and then slowly that builds to form a column, right? So that is known. So that tells me that as long as you get these fine particles, it doesn't matter how you get, correct? As long as you get fine particles, you should form columns, right? That's my hypothesis, whether right or wrong. Nobody's done that before using solution precursor, but we have spent a lot of time and we've had the conviction that it happens because you saw this slide yesterday. What am I saying here? That if you get fine particles, it should form columns. And what did I show you yesterday or day before? That if you do things right, you get particles, right? So if you do right, you should get columns as well, right? And that's exactly what we have shown, right? This is This is a hot result. We have not even published it yet, but now we are able to get columns without using any powder, without using any alcohol. So a lot of people are interested in this. Yeah. So that's one example of research. Correct. It also gives better life than what is state of the art. So this is just one way of how you can process coatings in a way that is different, that is not known. Maybe you have smart ideas to do that, right? That lady back there before lunch was asking me, oh, I do cold spray and I lose lot of powder. Yeah, lot of powder is being lost. How can I minimize loss of powder? Correct? It's not easy to minimize loss of powder many times. If you look at data, on an average, thermal spray has an efficiency of 50 to 60%. Yeah, if you do it really good, 70%, right? So 30 to 50% of the powder is just going, yeah, because it doesn't deposit. It doesn't deposit for a variety of reasons. Yeah, imagine something like this being sprayed. Yeah, you're spraying, the gun goes to the side, you spray, gun goes to the side again. Why does the powder not get deposited all the time? For several reasons. One is the inherent deposition efficiency is limited, right? The coarse particles don't melt, don't plasticize, they bounce off. Yeah. Then when the gun is on the side, it is still spraying powder, but there is no substrate there. So that is going. Depending upon the size, the powder flow goes like that. The sample is in between, so you may be losing powder above and below that, right? So what can happen? Some of this powder, which doesn't deposit, but it hits the substrate, falls on the floor. Some of the powder, when the gun is on the side or is the plume is beyond the size of the specimen, goes there and goes to the exhaust and is collected in a filter, right? So there are two sources of waste, what falls on the floor and what goes and gets collected in a filter. So 3-4 months ago, there was a call for funding, which spoke about sustainability. And then I wrote an application on reuse of thermal spray waste. That application got rejected, by the way. I didn't get that application, but I didn't stop working, right? We have continued to work on that. So we have had one company in Denmark carefully collect the waste from the floor, carefully collect the waste from the filter or the exhaust. So this is what a virgin powder looks like, average particle size of about 40 microns. This is what powder collected on the floor looks like, about 20 microns. And this is what the powder which is collected in the filter looks like, about 7.6 microns. It has large chunks, right? Some of these, what do they look like? Some of these, they look like this, right? Yeah. So they have not shattered or anything. They are, my guess, they are coming from when the gun is away from the substrate and it's just getting sprayed. Nothing else is happening to that, right? In some other cases, not from this guy, we have also asked similar thing from somewhere else, because this was HVOF spray. My ambition is to look at what happens with HVAF waste, what happens with plasma spray waste. I am looking at all of those. So here looks like this. From some other supplier, you see chunks of alumina. This is incidentally tungsten carbide cobalt. Very expensive powder, extremely expensive powder, right? So if I can get anything sensible out of this, I am in good shape. Right now, these people pay money to get rid of this waste. First of all, powder is wasted. Then you have to pay money to get rid of that wasted powder, because it's categorized as hazardous waste, right? So if I can get anything out of this, then I am in good shape. Then I can go to my funding agency and say, you are stupid, you didn't fund my project, but you should have done that. I am doing this on my own at the moment. What I started saying was, from some other supplier, we see chunks of alumina here and little bit here. Why do we see alumina? Some of you work in thermal spray. Why do I see alumina along with my tungsten carbide? Correct. Yeah, because they use alumina for grid blasting, so that is also falling on the floor. Yeah, sometimes that's also getting collected in the exhaust. So from a different vendor, I find no, this is a I'm not showing that result, but this is a blow up of the same powder. So yesterday we sprayed this powder. I was not there, but I asked my engineer to spray, and we are getting fantastic coatings. We don't know the quality, but it sprays well. We have not even sieved, we are not even separated. We have just taken what came and we have sprayed that. So I'm very curious to see what happens, right? But I'm very excited. Very good question. So every spray booth is different, right? Let's say my spray booth. I'm spraying M. Crawley today. My M. Crawley, after that, will have yttria stabilized zirconia. Tomorrow I may be spraying tungsten carbide cobalt. So if I collect the floor or the filter, I will have all these powders, right? So initially that's a bad example, right? And I think people who spray like that are not so interested in collecting that waste. It's a bad example. But there are many job shops that spray rolls from that wall till here, right? 5-meter roll, right? 2 meters big. So they are spraying a roll for 2 days non-stop with tungsten carbide cobalt, spending so much money, wasting so much powder. So for them, if my results are good, yeah, it makes lot of sense to say, okay, I am going to clean the floor chakachak, I am going to clean my filter, and I am going to collect what I am wasting over 2 days of non-stop spraying, yeah, and collect that tungsten carbide cobalt. So that is our aim. We will see what happens, right? So for me, that's also a good research area. Let's talk about coating of AM as my last example, because this course was about AM and it was about coating, right? So one question we are trying to ask is, are as-built AM surfaces directly suitable for coating, or do you have to do something? Yeah, do you have to do some pre-treatment before they can be coated? Yeah, so this project begins to ask these kind of questions. What happens? What do you think happens? Are as-built surfaces ready to be coated, or what does your common sense tell you? Are they ready to be coated, or you will have trouble coating as-built? Correct. Too rough to be coated? Maybe.
EBM, I think the roughness is acceptable for coating. Maybe wire-based DVDs like laser or arc.
Very good. You have given half the answer. Anything? Anybody else? Yeah. Our favorite answer. It depends. Yeah. It depends. Right. So as you rightly said, the surface roughness is very different depending upon how you build. Yeah. Maybe wire-based VAM will have very rough surface. EBM also very rough. SLM maybe not so much, right? So each surface is different in as-built condition, and requirement of each coating process is also different, right? So when we started this, I said my bet is that if you try to answer this question, it will depend on how the AM build AM part is built. One. Second, which coating do you want to put on that? Yeah. So the answer that I get for thermal spray may not be the same answer for PVD or electrodeposition, right? And the answer that I get for EBM may not be the same for SLM, correct, for a given technology. So, we have been looking at that aspect, doing many things, started with HVAF for example, right, and then we find that your interface looks very different. This is an AM interface, yeah. This is an SLM interface. So, interface looks different, but we are able to get pretty good looking coatings, right, no problem with thermal spray, looks quite nice, right. And now we have started to look at other coating methods, electrodeposition, PVD, right. And then, so this is an example of PVD done at ARCI for me on request on my EBM sample, and then you can see how it looks like. On the face of it, it looks very nice, yeah, everything is coated, it follows a profile that is available on the surface of the as-built layer. But if you look at these peaks and troughs, the thickness of the coating is very different inherently, right, extremely different, right. So, if you zoom in, you get very different thicknesses if you have surfaces like that, correct, very different, yeah. But if you polish the substrate, then doesn't matter if it is EBM, SLM or whatever, you get same kind of coatings, right. If you don't do that, it's very different, correct. So, for me this is also a very interesting area of research, correct, if we combine AM and SLM. So, I am going to stop here. These were just examples, but I would like you to remember where I started, yeah, and that is so important according to me, because you will spend a lot of time doing all this kind of stuff, funny, crazy, frustrating, bringing you joy, whatever it is, yeah, at different times. This is very important, yeah. Whether you get good results or bad results, it should be an area of your interest and passion, yeah. So, happy researching all of you, yeah, all right, thank you.